KK8BYP with a topic I neglected to put up on the 20-meter dipole testing. Here's the scan from the TAPR VNA. And by the way, this is not a correct use for VNA. That's a different topic. But these kind of results are unheard of in amateur radio. These kind of results, this kind of bandwidth flatness is a thing of antenna engineering. But this is a sweep of my 20-meter dipole at 17 foot, 8 inches, arms stretched tightly. The antenna's arms, not mine. SWR is 3 at 16 megahertz. That's, in theory, dangerously high SWR, but it's 2 megahertz up. Antennas in amateur radio do not exist that are that broad. And over here are the impedance measurements. Start frequency 13.8, stop 14.35, and for all practical purposes, the trace is dead flat. The blue is the resistive value, R value, at 25 ohm ticks, so about 75. The red is the so-called reactance. On the left, capacitive, and on the right, inductive. But that is essentially zero. And the impedance is at the top. So you can see how little it deviates across about 500 kc. 0.8 up to 0.35, 0.2, 0.55 megahertz. I have not measured it going down. I don't know how much below 14 megahertz it goes to have an SWR of 3. Interestingly enough, it works on 17 meters. Not great, but it works. But the point here is that these are the values. 13.9 at the low. It's 72.3 minus 7.7. Do the square root of the squares, that's 73 ohms. And at 14.34 at the max, that's not the total sweep width, those are just the points I ticked on the graph. 73.5 plus J13, which plus is inductive. The square root of the square of those two figures is the square root of the squares, which is the process for finding the magnitude Z of 73.5 plus 13.7 is 74 3/4 ohms. A 1 ohm change. This is absolutely unknown in amateur radio in general. There are a couple of us that I think have probably gotten similar results, but very few. And this kind of bandwidth is entirely due to pulling the antenna arm straight, daring to contradict those hams of us that say it doesn't matter if it sags. Oh, it makes a world of difference, because that sagging at the feed point makes a parallel component between the two arms and induces feed point admittance, capacitance. And the bandwidth goes right down the toilet. I mean, to put it generally, think of just throwing a capacitor on the feed point. What's that do? Well, it does bad things. Making those arms have a parallel component, especially at the feed point, allows a greater E field between the arms. And in my experiments with this antenna, taking that out is what caused this very wide bandwidth. This is almost 4 megahertz wide, which is just unbelievable. This antenna seems to be extremely directional. Several college professors, university professors, have no explanation. One individual I talked with suggested just getting an old FSM, which is not flying spaghetti monster, but field strength meter. Just a good old-fashioned that. $5 at the flea market with this little hinky-dinky rod antenna. That goes as such, and pull the good old AM/FM radio antenna. But just that, and take it out and see what happens. So I did. I had theorized that there was a spike in the emission, a very narrow emission because of a tree at the feed point. Boy, was I wrong. I was theorizing reflection off the ends of the arms coming back and colliding at the feed point, which is what I want. That ain't what's happening. And this is how some of our theories get flushed right down the commode when we do measurements. But what's happening is this. I measured a huge spike at the ends of the antennas with 1 watt transmit power, or at the end of the arms. No field anywhere else. Absolutely not what I expected. I expected a little bit at the ends because of the reflection, but I expected the larger amount at the feed point. And that was measured by holding this unit radially in line between the wire and ground. Like this, straight up. When I tilted it, the reading went down. And when I held it by the tape, the reading went way down, which shows that the coupling is from the antenna into the rod antenna, through the detector to the cabinet, to my hand to ground. So I'm ground there. But I think what that indicates, and I am far from an expert here because I've never done real antenna testing, is I think that indicates M field. Because I think the theory is that this orientation's E field, and I think that one's M. But I think the theory is that this orientation has M field lines cutting across the antenna and inducing energy in it. So don't quote me without that caveat. But this kind of emission, and granted, I didn't measure this up and to the side or over the antenna. I can't reach up there. But if it's planar, if those are two planes, that defines an extremely narrow emission, which is absolutely contrary to dipole theory in every way. Because dipoles, even in the engineering class, are treated as basically half isotropic, 2.3 dB sub I, which if you take a dipole in free space and assume it's emitting in a sphere and then put it above a plane ground, that cuts off half the sphere, so therefore it's half isotropic, yada yada. This is anything but. And there, in Tennessee vernacular, there ain't no way I should be able to work the next county on 20 meters with 1 watt, let alone reliably to Europe with 1 watt without some kind of pattern like that. It's impossible, because realize that this kind of emission is, in basic electrostatics, is reckoned as a charged particle, and this imaginary sphere around it, and the particles giving off field lines in every direction equally, and the intensity at any point in space is that energy falling on the surface of that spherical plane. No, that doesn't make sense. Planes aren't spheres. But on the surface of that sphere, under the square law. So the energy isn't lost. It just spreads out according to the square law and go out miles and hundreds of miles and thousands of miles. It's extremely weak. So the only thing that can account for this is some kind of very highly directed emission. And Yagis don't even do this. So whatever it is, it's working. I can't find anyone else that can even begin to explain it, even at the university level, because this doesn't happen. So that's where I'm at with this. I think I know what's causing it. It's very strange. I'm not going to say. just in case there's anything unusual and patentable there. I doubt it, but for what it's worth, there it is. Did it.